It's in your windows, your phone screen, your car, your kitchen. You use it dozens of times a day without thinking about it. But glass, one of the most useful materials ever created, starts as nothing more than ordinary sand. This is how glass is made. The main ingredient in glass is silica sand, also known as silicon dioxide, but not just any sand. The sand used for glass making is a specific high-purity variety, almost entirely free of impurities like iron, which would give the glass an unwanted green tint. To this sand, manufacturers add two critical ingredients. The first is soda ash, sodium carbonate. Soda ash lowers the melting point of sand dramatically from over 1,700 degrees Celsius down to around 1,000 degrees. This makes the whole process far more energy efficient. The second is limestone, calcium carbonate. Limestone is added to give the final glass durability and stability. Without it, glass would slowly dissolve in water over time. These three ingredients, sand, soda ash, and limestone, are the foundation of almost every piece of glass you have ever touched. The raw materials are carefully measured and mixed together in precise ratios, then fed into a large industrial furnace. Inside, temperatures reach up to 1,500 degrees Celsius, hot enough to melt steel, hot enough to turn solid rock into flowing liquid. The mixture melts slowly and completely, transforming into a thick, glowing mass of molten glass. At this stage, it looks almost alive, moving like slow, luminous honey, glowing deep orange and red. To improve quality, cullet is often added to the mix. Cullet is simply recycled, crushed glass, offcuts from previous production runs, or recycled bottles and jars. It melts faster than raw materials and reduces the energy needed, making the whole process more efficient and more sustainable. The molten glass is kept at high temperature and stirred continuously to remove air bubbles and ensure a perfectly uniform mixture. Once the glass is fully melted and refined, it needs to be shaped. The method used depends on what the glass is for. For flat glass, the kind used in windows, mirrors, and phone screens, the world relies almost entirely on a process called the float glass process, invented in the 1950s by Sir Alistair Pilkington. The molten glass is poured continuously onto a bath of molten tin. Because glass is less dense than tin, it floats perfectly on the surface, spreading out naturally into a flat, even ribbon. As it travels slowly along the tin bath, it cools and hardens gradually. The result is a perfectly flat, perfectly smooth sheet of glass. No grinding, no polishing required. For glass bottles and containers, a completely different method is used. A measured blob of molten glass, called a gob, is dropped into a mold. A burst of compressed air is then blown into the gob, inflating it outward against the walls of the mold. This is called the blow-and-blow process, and it can produce hundreds of bottles per minute. For handmade and artistic glassware, the ancient craft of glassblowing is still used today. A glassblower gathers molten glass on the end of a long metal pipe, then blows and rotates it continuously, shaping it with breath, gravity, and simple hand tools. It is one of the oldest manufacturing techniques still in active use. Glass that cools too quickly becomes dangerously weak and brittle. Rapid temperature changes create stress fractures inside the material, invisible to the eye but enough to cause it to shatter unexpectedly. To prevent this, every piece of glass goes through a process called annealing. The glass is passed slowly through a long oven called a layer. Inside, the temperature is carefully and gradually reduced over several hours, allowing the glass to cool at a controlled, even rate. This relieves the internal stresses built up during forming, producing glass that is strong, stable, and safe. Without annealing, the glass you drink from could shatter in your hand. The window beside you could crack from a slight change in temperature. It is a quiet but essential step. After annealing, flat glass is cut to size using diamond-tipped cutting tools, the only material hard enough to score a clean line. But not all glass ends its journey here. Tempered glass, used in car windows, phone screens, and shower doors, is reheated and then rapidly cooled with jets of cold air. This creates a compression layer on the surface that makes it up to 5 times stronger than ordinary glass. And when tempered glass does break, it shatters into small, blunt pieces rather than sharp shards. Laminated glass, used in car windshields, is made by bonding 2 sheets of glass around a thin layer of plastic. When it breaks, the plastic holds all the pieces together, preventing the glass from collapsing inward. Coated glass can be treated with thin metallic layers that reflect heat, filter UV light, or even generate electricity as solar panels. What starts as a handful of sand ends as something that protects you, connects you, and quietly holds the modern world together. Sand, soda ash, limestone, heat. 4 simple things, 1 extraordinary material. If you found this fascinating, subscribe to Genius Rodeo. Every week we go inside the processes behind the things that shape our world. We'll see you in the next one.